This is Calculus 2. This session, we're going to study alternating series test. So far, we have learned divergence test, integral test, comparison test. In series, each term is positive, but now we're going to study alternating series. Then we're going to discuss alternating series test. First, we're going to review what is alternating series. Alternating series is going to be change the sign. For example, here, right here, guys, is summation n equal 1 to infinity, summation n equal 1 to infinity, -1 n minus of bn. Bn is all the bn is positive, okay? So let's start n equal 1. That's going to be -1 and 0, b1, -1 and 1, b2, -1 and 2, b3. So look at this series. -1, 0 is 1, b1, -1 to 1, -b2. Here is b3, b4. This series is going to be alternating sign. That's going to be alternating series. So, okay, that's going to be you guys are thinking about alternating series form. Here is alternating sign. So there's no one way, right? Alternating series. So many different way. Best way, you're going to always expand it. For example, another example is a summation an summation n equal 1 to infinity, -1 and n bn. Start 1. Okay, then -1 and 1 power -b1. Next one is b2, -b3, positive b4. So always you expand the series, you're gonna see sign is alternating. We call this is alternating series. Now, check it out, the two series right here. Sometimes the first one is they write this way. There is not one way write the series. Second is write this way. What is the best way? You know this is alternating series or not. You just expand it. N equal 1. N equal 2. N equal 3. N equal 4. Okay? -1 and half, 0. That's going to be 1. Second is -1 and n power is 1 is -1 and a half. Here is negative is square is positive. It's going to be 1 over 4. -1 over 8. See? Positive, negative, positive, negative. That's alternating series, guys, okay? Let's do the second example right here. Summation n equal 1 to infinity, -1 and n minus 1 over n. You clearly this term, which meaning is alternating sign, but make sure this is alternating series. Let's expand it. -1, 0 over 1. -1, 1 over 2. -1 square over 3. -1 cube over 4. So -1 power is 0 is 1. 1. -1 power is 1 is negative. -1 and a half. -1 square 1 over 3. Cube -1 over 4. Guys, clearly see alternating sign positive, negative, positive, negative. So we call this is alternating series. Alternating series, they have special tests we're going to use. I'm going to introduce alternating series test. What is alternating series test looks like? Guys, you have to check two things. The first one is going to be Here is alternating series. It looks like -1 and -1. Bn is gonna be all Bn is positive, guys. Bn is positive. So you have checked the limit of Bn first. That's the first check. You have checked the two conditions. Bn is limit of Bn is going to 0. Bn is, remember that this is decreasing sequence. Bn should be decreasing. Another way, B1, B2, B3, B4, that's decreasing. Then we're gonna say this series is gonna be alternating series gonna be convergent. Okay, so alternating series, you see, you drop the sign, only get the number, find the limit. Second part, you have proved that's the decreasing. Then this series is gonna be convergent. But another big thing is alternating series doesn't give series gonna be diverse. Only you can check series gonna be convergent. Alternating series test doesn't say this series gonna be divergent or not. Only series gonna be convergent when they satisfying these two conditions. That's how to use alternating series test. Let's have the example here. First one, guys, here. First one, what condition you have checked? Here is right there, A. So first, what is B and what is the change here? Look at this -1 and n -1. Clearly, this gives the alternating sign, right? So you have find the Bn, 1 of n. So first checking is limit Bn, limit n approach to infinity, 1 of n is 0, right? Second is you have check decreasing. B1 is 1, B2 gonna be 1 over 2, B3 gonna be 1 over 3, B4 gonna be 1 over 4. That's decreasing. Then our conclusion is this alternating series gonna be converged. Guys, understand that? Let's expand this one, guys. What happened here? N equal 1 to infinity. Expand it. N equal 1, 1 over 1. N equal 2, 1 over 2. N equal 3, 1 over 3. N equal 4, 1 over 4. This one is gonna be converse, okay? Because we check the condition 1, limit of general term going to 0. Second is sequence gonna be decreasing. That's this alternating series gonna be converged. Let's do the second example. Same thing here, guys. Look at this one now. Look at this one. That's give the alternating sign. So we find the Bn 1 over 2n. Right, guys? So we want to find the limit of this sequence, and then this one is decreasing or not. So let's find this limit, n approach to infinity, n to n. So this limit is gonna be what happened, guys. You're gonna using L'Hopital rule. Let's check this going to infinity, this going to infinity. Limit n approach to infinity. Derivative n is 1. Derivative 2n. I'm gonna write down here. 2n is derivative gonna be 2n times ln2. So 2n times ln2. And approach to infinity, where do you go? This one going to 0 because denominator is getting bigger. So general term going to 0. Second is you have check what is B1? 1 over 2. What is B2? 2 over 2 square. That's 1 over 2. B3 gonna be 3 over 2 cube. 3 over 8. Can you get the idea? This one is the same. But 1.5, 3 over 4 is B2 is bigger. That's decreasing. So you're going to conclusion is by alternating series test, we're going to say this alternating series going to be converge. Okay? That's you're going to find it. Let's do the C. Let's do the C, guys. So what part of saying alternating series? This one is say this is alternating series. So then what is Bn? That's gonna be 1 over n squared. Let's find the limit of this sequence. That's gonna be limit n approach to infinity 1 over n squared. That's gonna be 0. How about this sequence is decreasing? B1 is 1 over 1. B2 gonna be 1 over 2 square, 1 over 4. B3 gonna be 1 over 3 square, 1 over 9. Definitely this is decreasing, right? So by alternating series test, so we're gonna say this one is converge. So alternating series test, first you identify this series is gonna be alternating series first. Then we have to find the Bn right here. What is Bn? Then you're gonna find the limit of Bn and you have check this Bn is decreasing. Okay? Let's investigate these two series. These two series looks similar, but totally different characteristic. Okay, so first one is gonna be right here, summation n equal 1 to infinity negative 1 and n minus 1 over n. So I want to expand n equal 1, that's gonna be 1, n equal 2 negative 1 and half, n equals 3 1/3, n equals 4 negative 1 over 4, right? Alternating series, right? This alternating series. What is this one? Summation absolute value negative 1 and n minus 1 over n. N equal 1 to infinity. Absolute meaning is no matter what here inside, no matter what, always positive. So what happened here, guys, when you expand it, 1 plus this inside the negative but positive 1.5. Here is positive, doesn't matter, negative is positive. Okay, so we prove, guys, prove. First one is converge by what? Alternating series test. Second is this one is diverge by P series P equal 1. Looks very similar, but one series converge, one series diverge. Okay, let's talk about this one is later. Let's giving one more example about that. Now to the second example. See, guys, B gonna be, look at this. Summation negative 1 and n minus 1 n square, n equal 1 to infinity. Let's have this one here, guys. Let's expand it. N equal 1, 1 over n square is 1 plus n equal 2. That's going to be negative 1 over 2 square, n equals 3, positive 1 over 3 cube, n equals 4, negative 1 over 4 square. So this is alternating series test that's converge. We already proved it. How about second one? Second one, summation n equal 1 to infinity absolute value. So absolute drop the sign, guys. So this one is 1 plus 1 over 2 square plus 1 over 3 square and 1 over 4 square. Okay, this one is also converse by P series. P series is gonna be P equal to. So this one is gonna be, this one is converse, this one is diverse, the second one is, this is converse, this is diverse. So I'm gonna explain something in the next slide about this property, guys, okay? So here this idea is one thing here, because here, second example, so let's see this infinity series, this infinity series. Which one is bigger? Which one is bigger? Look at this. Positive, negative, positive, negative. So definitely n equal 1 to infinity, negative 1 and n minus 1 and n square. Summation n equal 1 to infinity, negative 1 and n minus 1 over n square absolute value. Of course, this one is bigger. You say you already know this is converse. Now, of course, this is converse by comparison test, right? Everything makes sense? So I want to explain new definition of this characteristic in the next slides. I want to talk about absolutely converse and conditionally converse, okay? So I say previous slides, we're talking about this one, guys. Look at this, AN. Summation is absolute value AN. Which one is bigger? Which sum is bigger? This one is always bigger, okay? Because this term might be alternating series, but this put the order absolute value, meaning is this one is, each term is a positive. First condition is, guys, look at this first one. They say this one is absolutely converse, meaning is, the first one is AN, guys. AN is absolute. Converse, convergent, meaning is when this one is converse, then this relationship, of course, this one is converse too. Okay? But second is, AN is conditionally converse. This case, this one is converse. But very careful, this one is converse doesn't guarantee right one is converse. So, but this one is diverse. Then we're going to say conditionally convergent. So I'm going to give you example in next slide. So what do you mean by this one, guys? Okay. Let's investigate this definition, guys. So look at the first one. You already proved it, guys, here. This is a sequence. What kind of sequence? Oh, no, I'm sorry. Series. Alternating series, guys. Alternating series. So we're going to check two series. We're going to check two series and convergence divergence. First one is this one. This series, 1 minus 1 and a half plus 1 over 3 minus 1 over 4. This one is converse. By alternating series test, right? Right? But look at this second part. You take absolute value, then drop the sign. So that case, 1 over n. 1 plus 1 over 2, 1 over 3. That's going to be diverse. So what I'm going to say here, guys, you're going to say this series is going to be conditionally converse. So you have to check both. So both are converse, then you're going to say absolute converse. This one is alternating series converse, but positive series going to be diverse. That's the conditionally converse. Let's go second example right here. Look at this one. So this one, let's check this one. This one is converse, right? Alternating series test. Also, each term, drop the sign. Each term is positive. That's going 1 over n squared. That's also converse. So we're going to say this one is absolutely converse. Which meaning is, guys, this one is converse. Each term is possible. Also, this alternating series is going to be converse. Then this is absolutely converse. But first case is this is diverse, but alternating series is going to be converse. That's the conditionally converse.